Hello, this is Nitin Dahad with the Times. I'm speaking to Giovanni De Micheli, who's a professor at EPFL. Giovanni, hello.
Hello, nice meeting you.
How are you?
I'm having a great time. Today I had the chance to give a keynote here at the conference and meet so many interested people.
Yes, so we're here at the HiPEAC 2025 conference. It's the 20th anniversary, and Giovanni, you gave a keynote speech this morning. What I quite liked about it was you addressed that big picture. I think you talked about the phoenix, but it's like the rebirth of computing and the socio-economic challenges for technology as well, and connecting the dots between the societal challenges as well as the technological challenges.
Well, we have unprecedented challenges in hardware design just to support machine learning and AI. And I think we need really a broad collaboration. We need collaboration among countries because of manufacturing capability and design capabilities. We need people. We need more people, more engineers to come and share their experience.
That's right, and I think one of the things you talked about is, a few things you talked about, the need, despite the rhetoric around the world about self-sufficiency and self-reliance, you highlighted very starkly how certain skills are in certain and capabilities are in certain regions, and even though we do some self-sufficiency, there still needs to be a stronger collaboration.
Absolutely, we do need. There's lots of talent. There are lots of engineers in the Far East, in Asia, and they are very welcome to come to Europe, as they are welcome to go to the US, but because they bring not only their skills but also enthusiasm. They like to work, they like to see a product. And when I talk to my European students in Switzerland, I try to tell them it's not that you do a job just for the money. You do it because you want to achieve something that stays.
That's right, and I think whenever I go to Silicon Valley, I see the passion. People want to achieve something. I think that's always been the complaint about Europe, isn't it? That we have the talent, but we don't necessarily have the passion in the way they do in Silicon Valley. And obviously, you're talking about Asian talent as well, being similar.
Yeah. Silicon Valley is an explosive mix of Americans, Asian, Europeans, and all together on this kind of common ground. People are able to do the unthinkable. And we couldn't do the same thing in Europe. I think that in Europe we have diverse cultures, and we have expressing slightly different values. But the combination of this is extremely good, and the interaction with the other parts of the world is also extremely good.
Right. It wasn't just about the global and geopolitics that you talked about. You talked about some of the challenges and needs for our AI-driven, data-driven technological requirements and computational requirements, and what's needed in terms of that diversity of technologies and architectures. Can you tell us maybe a bit more about that?
If you look at the future systems, look what we want to achieve within the energy budget that we can afford, then we need to open up. We need to have more diversity in the realization in terms of heterogeneity. So we need to be able to find, for specific function, the fabric, the computational fabric that can match the computation. This is not to say that CMOS will disappear. CMOS will stay. It will be actually the material that will connect everything together. But for achieving specific objectives, we will need accelerators.
Yeah, and you gave some examples. Can you maybe touch on one or two examples of some of the diversity of architectures and technologies that maybe supplement CMOS?
The most striking one is the computation of matrix time vector. These are operations that happen all over in machine learning algorithms. And you want to speed them up, and there is a significant advantage if you can speed them up. And you can do them with CMOS, you can do them with specialized structures in FPGA, but you get the best bang for the buck if you use specific technology. In my slide, I've shown one realization that was done at EPFL by a colleague of mine, Andras Kish, and uses a new material which is molybdenum disulfide, MOS2. And it's a very interesting material because this is flat electronics, single layer electronics, and allows very low power realization of computational functions.
That's impressive. And I think the other thing is the heterogeneity is something that we've already embraced in designs for a long time anyway. But I think the question is, I think people now need to understand that this will take us to the next level in terms of computing.
Absolutely. The next level will be just mixing and matching various type of devices, various type of architectures, and try to achieve the best. Keep in mind that if we look at AI application now, we are 1000x far away from the level of energy that we want to put in the computers. This is not to say that we will never have an engine in our watch that would run, but will not even be able to have a decent data center in the enterprise for supporting engineers, supporting design, just because of the power needs.
One interesting thing you said, and I think it's something people misunderstand with AI in design. And I've been talking to all the EDA companies, and they talk about how all this AI design tools are going to make complex chip design better. But you said something interesting, which was you don't believe AI will design in the way, ingenuity of an engineer. And I think that, just elaborate on that, because it's actually quite important for people to understand the balance.
I think AI will be great to better the current tools because AI can capitalize on the previous experiences in design.
Yes.
But when you have something new, you have to do this step ahead. You need to have this ingenuity, you have to have this sensitivity towards the new type of product that you are designing by knowing also what is the array of technologies that you have. This kind of guess, this educated guess, is something that a human can do and not an engine. Yeah. I strongly believe that.
And I think I tend to agree with you. But lastly, we're here in Europe, the HiPEAC. One of the things I think I was having a discussion with somebody this morning. This is a fascinating research community, but I think the translation into people understanding what's happening here is not so well known. And I think that's part of not just the research community, but also the European mentality. What do you think needs to be done in Europe to address some of the future challenges?
I think there is a real need of broad education. That is, letting people know what technology does for them. Yeah. You just don't buy a smartwatch or a telephone at just a box and you rely on that. You have to understand the effort in designing it so that you can use it better. And also you have to make people know that it's interesting and rewarding to work in this domain. And this is something that we in Europe sometimes neglect, but the technology jobs are great. And we have fantastic industries in manufacturing semiconductors, fantastic industry in doing vehicles, planes, cars, but still in the computer domain, Europe is lacking behind.
Okay. And what's your final thoughts for this conference? What do you think after 20 years? I mean, you must have attended a few of these. What's your thought on this conference?
It's a great conference. It's great to get together. It's great to see people who have been active for so many years and change opinions. I think conferences have the big value of networking the people, and that's what I enjoy the most.
Well, Giovanni De Micheli, thank you very much.
Thank you.